Welcome back. In today's session, let us continue with part 2 of the series, Write PySpark Joins like a pro. In part 1, we discussed join types in detail. So for this session, I assume that you are already familiar with join types. In part 2, we will shift focus onto how to write join conditions. In other words, how to join data frames. This session is a guided tour of working examples that I have put together in a Databricks notebook. These working examples are based on tables in a TPCH database of samples catalog, which comes along with the Databricks free edition. What you see on the screen is an entity relationship diagram of tables in TPCH database. There is plenty to explore. So, at first, let us take a quick sneak peek of what is included in this video. In this guided tour, we will walk through several scenarios for joining data frames. Single column joins, multi-column joins, multi-table joins, self joins, joins using string literals, and finally, a few tips and tricks for writing joins. For each scenario, there are two categories of examples. One category of examples are based on aliasing data frames before performing the join, and another category of examples based on aliasing the data frames inline while performing the joins. And under each category of examples, you would see two examples. One example using dot notation to access the columns, and another example using column function to access the columns. By the end of this session, you will have a solid understanding of different ways to write PySpark joins, and you can choose whichever approach best suits your needs. Sounds good? All right then, let us dive in. Here we are in the Databricks notebook. First things first, let me first refresh our memory on the PySpark join syntax. PySpark join takes two data frames. Data frame 1 join with data frame 2 on which columns we want to join the data frames. In other words, what's the join condition followed by the join type. About the join type, we discussed in detail in part 1 of the series. So, in this part 2 of the series, we will focus on how to write the join condition. That's about the syntax. Moving on, what you see here is the entity relationship diagram for TPCH database. This TPCH database is part of the samples catalog that comes along with the Databricks free edition. Most of the example data frames in this notebook will be populated with data from the tables in this TPCH database. That way, as you can see here, all these example data frames, DF customer, DF orders, DF line item, and so on, they are getting populated from the tables in the TPCH database. Before we start writing a PySpark join, we need to decide on at least four key points. One, which join type to use. Two, which columns to join the data frames on. Three, choosing a column access method. Then four, choosing a data frame aliasing approach. Let us discuss briefly about each of these four aspects. Join types. Which join type to use is driven by the functional requirements. In the examples in this notebook, for most of the examples, I have used the inner join type, but as you may already know, switching the join types is simple and straightforward. Which columns to join the data frames on? This is driven by the entity relationship between the tables that you want to join on. Column access methods. You may already know that there are several different methods to access the columns in a PySpark data frame. Keeping this in mind, I have put together a blog post recommending the best practices. As per my recommendations, there are two different approaches that we can take. Option A is to use the column function for most of the transformations, and option B is use the .NET notation for most of the transformations. Either option works well. So, keeping in line with my best practice recommendations, the examples in this notebook contain both types of examples. Each example will be written using the .NET dot notation approach as well as column function approach. Does that make sense so far? Now, let us talk about data frame aliasing approaches. There are two different approaches to alias the data frames. In the first approach, the data frames will be aliased before using them in the join transformation. Whereas in the second approach, data frames are aliased inline along with the join transformation itself. Let us go through the details of it to understand it better. Aliasing data frames before performing the join. In this approach, we alias the data frames first before we use it anywhere else. So here, as you can see, the data frame DF customer and DF orders, those data frames have been aliased to new names. And it is these alias names of the data frames that are being used in the join transformation. Because they are being aliased and referenced in two separate steps. So that is where I was calling this approach as aliasing data frames before performing a join. The benefit of this approach is that we could use either dot notation or column functions to access the columns in a data frame. Now let us take a look at the second approach, which is aliasing data frames inline as part of the join transformation itself. In this approach, as you can see, the original data frame names are being aliased to the new names, and it is these alias names that are being used in the join conditions in this example. The limitation of this particular approach is that with the aliased column, aliased data frames, you could use only column functions to access the columns in the aliased data frames, whereas you cannot use dot notation to access the columns in the aliased data frames. So that way, my personal recommendation in terms of which data frame aliasing approach to use is that I would prefer aliasing the data frames before performing a join, because in that case I would be able to use either dot notation or column function to access the columns. Then my second preference is to alias the data frames inline while performing the join itself. But in such a case, we need to be aware that we cannot use dot notation in accessing the columns. We could use only the column function to access the columns. I hope that is clear up to this point. Now, let us move on to more interesting stuff, which is about discussing various join scenarios. Let us start with single column join. As indicated earlier, there are several different scenarios for column joins, single column joins, multi-column joins, and so on. For walkthrough of each of these scenarios, the approach I want to take is that first, we will take a look at the illustration that describes the join scenario. Then, we will go out to the Databricks notebook for a look at the relevant sections of the code. Hope that is okay with you. All right, let us dive in. Let us start with single column joins. As you can see on the screen, for single column join scenario, we have two data frames, customer data frame and orders data frame. These two data frames we want to join on customer key. So let us switch over to the notebook and walk through the code for the same. Just a quick reminder, the examples in this notebook are fully functional. However, we won't walk through each one in depth. In the interest of time, I will take you through the single column join in detail and then briefly skim through the remaining examples. Along the way, I will highlight key takeaways. With that said, let us take a look at the code for the single column joins. The example that you see on the screen, the example code that you see on the screen takes the approach of aliasing the data frames before performing the join, and dot notation is used to access the columns. In this approach, broadly, there are three steps. Step one is to alias the data frames that we want to join. And then step two is to write the join transformation itself. And then step three is to select only those columns that we want in the output. Now, let us go into a bit more detail about each of those steps. In step one, as you can see here, we have customer data frame and orders data frame, which were the original data frames as we loaded from the database table. And those two data frames are here being aliased to new names. So that way we have df customer alias data frame and df orders, the df order alias data frame. So here we have done the aliasing of data frames, which is step one. Having aliased those data frames, now moving on to join transformation itself. Here we are specifying the first data frame, which is df customer alias, and join with the second data frame, which is df orders alias. Then we are specifying here the join condition. The join condition here is that we want to join both the data frames on customer key. So that is the join condition followed by the join type. So the whole thing is the join transformation, wherein we specified the first data frame and the second data frame that we want to join on, and the join condition itself followed by the join type. Then in step 3, as a best practice, we want to select only those columns from the input that are really required as part of the output. rather than selecting every column as part of the output. Hope that makes sense. That's it to writing a single column join transformation. The overall structure is more or less the same, whether you are writing a single column join or multi-column join. Before we move on, I just want to show you something. If you look at this table of contents, you can notice that we have these examples for the single column joins, multi-column joins, multi-data frame joins, and all. And for each scenario, I have written the examples taking different approaches. Aliasing the data frames before the join, aliasing the data frames in line with the join, and under each approach, each category, examples included a dot notation examples as well as column function examples. So feel free to explore them in your free time and use the ones that suits your preferences. With that, let us move on to multi-column joins. The join scenario that we have for multi-column join is we have two data frames, line item data frame and part supplier data frame. And we want to join these two data frames on part key and supplier key. So let us see what this looks like in the Databricks notebook. Multi-column joins. The example code that you see on the screen is taking the approach of aliasing the data frames before performing the join and using a dot notation to access the columns. In terms of overall code structure, it is more or less the same, regardless of whether you are doing a single column join or multi-column join or multi-table joins. What I mean by that is, in this particular approach, we first alias the data frames and reference those aliased data frames in the join transformation, followed by selecting the columns for the output. Having said that, the main difference between join scenarios is the join condition. In this particular join scenario, wherein we wanted to join multiple columns, here we wanted to join the two data frames on the part key and supplier key. So that way, part one of the join condition is to specify the join between the two data frames on part key. And then the second part of the join condition is to specify the join between the two data frames on supplier key. Joining on part key between the two data frames and joining on supplier key between the two data frames. Here is one key takeaway that I would like to mention about is that each part of the join condition, we need to enclose them in parentheses. And all these parts of the join condition as a whole optionally can be enclosed in square brackets. If that makes sense, let us keep going. In this multi-table joins scenario, we have four tables to join: line item, part supplier, part, and supplier. Of these four tables, we have already seen the table joins between line item and part supplier in the previous example. wherein we joined the path key between the two tables, similarly the supplier key between these two tables. Now we want to extend the table joins to include path table as well as supplier table. So for this, what we will do is we will be joining using the path key in the path supplier table to join the path table. Similarly, we will be using the supplier key in the path supplier table to join with the supplier table. So that way, overall, there would be three join conditions we will be writing as part of this join scenario. First one is the join between the line item and path supplier. The second join condition is between path supplier and path. And the third join condition is between path supplier and the supplier. I hope the idea is coming through clearly. Now that we have seen the concept visually, let us jump into the code to see it in action. Even in case of multi-table joins, the approach we take to join those multiple tables is no different to what we have seen in the single column joins and multi-column joins. In our case, we want to join four different data frames. So we start by aliasing those four data frames. And it is these aliased data frames that we will be referencing in the join transformation. In the join transformation itself, we start by joining the first two tables. And in this case, we are joining line item data frame with the part supplier data frame. And we are joining those two data frames on the part key and supplier key. Having joined the first two data frames, including specifying the join condition, now let us move on to add the third data frame into the equation. And this is how you specify it by calling the join method on the data frame. And this time around, you pass the third data frame name to join with. And while doing so, we want to specify that this parts data frame, we want it joined to the part supplier on part key. And this is how you specify that join condition. Part supplier, join it with parts data frame on part key. Having joined the third data frame, now let us go on to join the fourth data frame by invoking this join method of the data frame one more time, and this time specifying the fourth data frame. And this fourth data frame supplier, we want to join it with part supplier on the supplier key. So accordingly, let us specify the join condition, wherein we specify this part supplier data frame and supplier data frame by saying that we want to join on the supplier key. So that is the gist of multi-table joins. Now that we have covered multi-table joins, let us move on to self-joins. To understand self-join, let us start by looking at a problem statement which can be solved by self-join. Suppose we have an employee table. Each employee is uniquely identified by their employee ID. Since every manager is also an employee, managers are represented in the same table and identified by their own employee ID. Additionally, most employee records have a corresponding manager ID, which points to the employee ID of their direct manager. Now, the task is how to retrieve employees' details along with their manager's name and manager's job title. This is where self-join comes into picture. Next, let us try to have a conceptual understanding of the self-join before we look into the example code on self-join. In simple terms, a self-join is a join where a table is joined to itself. What it means is, while writing PySpark query, you make two logical copies from the same employee table. Logical copy 1, logical copy 2. Let us call the first logical copy as the employee instance and the second logical copy as the manager instance. In other words, employee instance represents the employee details and the manager instance represents the manager's details. Does it make sense? Just to make sure we have a clear conceptual understanding of self-join, let us look at the data in the two instances of the employee table side by side. Here is the data for the employee instance, and this is the data for the manager instance. As indicated earlier, employee instance represents the employee details, whereas the manager instance represents manager details. Now, let us say we want to retrieve the details for employee ID 104. While most of the employee details are available in the employee instance itself, we don't have the manager's name and manager's title in this employee instance itself. However, we do have the manager ID for Jack. So knowing the manager ID and also knowing that this manager ID is just another employee ID, what we can do is take this manager ID from employee instance and go into the second instance, which is the manager instance, and there look up for this manager ID 104 as employee ID in the manager instance table. Once we find a match, we can determine what the manager's name and job title are. In other words, all we have to do is join these two data frames, the first instance of the data frame and second instance of the same employee data frame, join them on the manager ID of employee instance with the employee ID of the manager instance. So that way we can retrieve all the employee details along with their manager's details as well. I hope that is clear up to this point. Next, let us see what this looks like in the Databricks notebook. Once our conceptual understanding of self-join is clear, understanding the code is very straightforward. So let us get into it. Here you can see that the employee data frame is getting populated with some mockup data. Now let us take a look at the code for the self-join. Just to reiterate, in a self-join, a data frame joins to itself. Keeping that in mind, you can see here the employee data frame is getting aliased into two separate data frames. One employee data frame and other one is manager data frame. In other words, the same employee data frame is getting instantiated into two separate instances, one employee instance and one manager instance. As indicated in the illustration, employee instance represents the employee details, whereas the manager instance represents the manager details. Then in the join transformation, those two instances are joined, like joining any two data frames. Here, the employee instance is getting joined with manager instance, and the join condition, as we have seen in the illustration earlier, manager ID is manager ID of employee instance is joined with employee ID column of manager instance. And let us pause for a moment to make sure this is clear. Moving on, there are two more points that I want to highlight. One is about the join type, and the second one is about the column aliases. Coming to the join type, I mentioned here left outer join rather than inner join. The reason being, while extracting the list of employees, I want to extract every employee regardless of whether they have a manager ID assigned to them or not. For example, a CEO of the company may or may not necessarily have a manager ID assigned to them. Then coming to aliasing of the column names, the scenario we have here is that one data frame is instantiated into two different data frames, and we are joining those two instances of the data frame. So in that case, what could happen is that same column names would appear in both the data frames. For example, we have this EMP name column. This column is present in employee instance as well as in manager instance. So if you had not aliased the columns, and then if you try to access this EMP name column in the output, then you would be thrown an exception on the lines of ambiguous column name. So to avoid that ambiguity in the column names, we should be aliasing the columns. For example, here the EMP name in employee instance has been aliased to employee name, and the same column EMP name in the manager instance is being aliased to manager name. Make sense? That was about self joins. Next, let us take a look at joins using string literals. The join scenario here is that we want to join the data frames using string literals. Say we have three data frames: orders, line items, and part supplier. While joining these data frames, we want to specify the join condition using string literals rather than using a dot notation or column functions approach. From solution perspective, we have to be aware of one prerequisite, especially if we want to use string literals as join condition. That prerequisite is that the column names which we want to specify in the join condition, they must be exactly the same between the data frames. For example, here we want to join the orders data frame using the order key to the order key in the line items data frame. So in this particular scenario, the column name which we want to specify in the join condition is exactly the same between the two data frames. So that way we are okay to use string literals in the join condition. Similarly, the join between line items and part supply. The columns on which we want to join is exactly the same. So we can use string literals as join condition to join such data frames. The key takeaway from this particular slide is that using column names as string literals is an alternative approach to dot notation and column function to write join conditions. However, the string literals approach has a limitation, wherein the column names to be joined must be identical between the data frames. Although we may not prefer writing joins using string literals due to its limitation, we may see examples on the internet that use string literals. So, good to be aware of this approach to write join conditions too. Let us switch over to the notebook and see the code. Finally, we are in the code walkthrough for the last of the join scenarios. I promise it to be a really quick one. For using string literals in a join condition, as mentioned earlier, the prerequisite is that the column names, the key column names that we want to join on must be identical between the data frames. So for that reason, I have created three new data frames wherein I ensured that the key column names, for example, order key column name is exactly identical between these two data frames. Similarly, the part key and supplier key is I ensure that it is exactly identical between the two data frames. Now, let us go on to see the join code itself. What you see here is a join between three data frames as we had seen in the illustration. The join between the first two data frames, orders and line items, is a single column join. And the second join, which is between part suppliers and line items, is a multi-column join. So you can take a look at the single column join first. In the case of single column joins, all we are doing is we are specifying that column name, which is identical between the two data frames. We are just specifying that column name without any data frame names, and that column name is being enclosed in double quotes or single quotes. So that is a single column join using string literals. Now coming to the multi-column join using the string literals. Here in the join between line items and part suppliers, the multi-column join, how it is being specified here is that each column name is enclosed in double quotes and separated by a column between the column names. And the whole of this multi-column join is wrapped in a square brackets. That's all for the joins using string literals. Also, that is everything about various join scenarios. Finally, let us wrap up all the discussion on joins with a few tips and tricks. Last but not the least, here are some useful tips to help you write PySpark joins more effectively. Here I have about 10 tips, and most of those tips are focused on the syntax in writing a PySpark joins. And for detailed explanation on these tips, you may want to refer to my blog post or the Databricks notebook itself, which I will be sharing in the GitHub. All right, that's it for today's session. If you have found this helpful, don't forget to like my video and subscribe to my channel for more content like this. In part 3, let us dive deeper into PySpark Joins to avoid common pitfalls in writing joins. Along the way, let us gain some practical insights as well. So make sure to join me in my next video, and together let us continue learning how to write PySpark joins like a pro. Thank you so much for watching.